In this video, let's continue the discussion about smart queues in the UniFi routers. In my previous video, I dig deeper into the technical implementation of UniFi's smart queues. In this video, we are going to focus on the speed testing to see smart queues in effect. Let's see whether it can resolve the buffer bloat issue. In the first half of the video, we are going to discuss 3 different ways to test the speed and the latency. And in the second part, I'm going to discuss for 4 different UniFi routers, UDM Pro, Uxg Pro, Uxg Pro, and UDR, whether the smart queues have any dramatic impacts to the overall performance and how it will tax the system. If you don't know what buffer bloat is, I strongly recommend you check my previous video about the UniFi routers smart queues explained. I won't discuss all the concepts and technical details. I will directly go to the testing. If you Google buffer bloat speed test, you can easily navigate to this web page from waveform. It's very user-friendly. You can use the same way as you test your internet speed. Just click a button. It will give you a very easy to understand grid, even give you the jitter. But in this video, I will not use this directly available tool. The reason is all my 4 UniFi routers are behind my existing firewall, which is pfSense. So they are not directly connected to internet. I don't want to bring in other factors. The other reason is if I use my real internet connection, everything I show will be limited to whatever my download and upload speed ISP gives me. It will limit my goal, which is to exhaust the bandwidth to really test the performance impacts. So for the 2 reasons, I won't use the waveform. If you are interested, try it. It's very user-friendly. On to my second way to do the testing. I'm showing you the diagram I'm going to use for this video. Here I use UDM Pro as the example. I put the router in my lab environment, and in my home network I have pfSense. It's my main router. It's connected to internet, and I use UniFi switches. Within my home network, I host a Linux virtual machine. It will be acting as the server in the WAN part. And in my lab environment, UDM Pro as the router, and I use a UniFi switch connect to another Linux virtual machine as the LAN side client. By using these 2 Linux virtual machines, I can do the performance testing. For this example, UDM Pro has 2 WAN ports. One is gigabit, the other one is 10 gigabit. For most of us, we have maybe maximally 1 gigabit internet speed. It may not make sense to test the 10 gigabit WAN port. So no matter what UniFi routers I test, even if it does have a 10 gigabit WAN port, I'm still going to use the 1 gigabit one in this video to really simulate the real world scenario. And the other thing I want to mention is the IP address or the VLAN. As you can see here, I stated for the WAN port, I have this 88 subnet, and for the Linux virtual machine in the WAN part, it also has the 88 subnet, which means whatever I'm going to test, it will not go via pfSense. I make sure all the traffics are just within my home network. Okay, let's get started. I'm going to use this type of screen layout in this video. In this corner, I show you the UniFi controller. As you can see, for the UDM Pro, I have the smart queues disabled. Let's first test what's the performance and the latency. For this corner, I show you the SSH. I'm going to log on to UniFi router. For now, let me only run the top command so that we can monitor the system resource consumption. And in the lower left corner, let me run 3 iPerf3 servers. They are going to monitor different parts. I run 3 servers because I want to really give the system a heavy burden so that we can see what's the latency situation. Okay, I already run the 3 iPerf3 servers. You may notice for each one I use a different port number. I still have some room in this screen, so I launch a activity monitor so that we can see the network traffic in a more straightforward way. Okay, move on to the very last window. I'm going to run the iPerf3 clients, and we are going to run a ping session. By using the ping, we can see the latency situation. That's exactly what the Bufferbloat issue is about. I already inputted the commands. As you can see, I simply run them as iPerf3 client. Each one will connect to a different iPerf3 server in the left side, and I specify the capital P10 parameter because I really want to tax the system. So I want to give it even more traffic. Even though it won't really increase the total throughput, it will introduce more packets. And in the very last window, I simply run a ping. Let me queue the top session, check the current system Linux traffic control queuing disciplines. If you don't know what I'm talking about, please check my previous video about the smart queues details. Let me simply run the command here. I say tc queuing discipline show del S8. S8 is the gigabit 1 port I'm using. As expected, it's simply using a multi-queue and for first in, first out fast queuing disciplines. In the left side, I already have the 3 iPerf3 server running, and now I simply start the ping. The time here, the latency is pretty good, only 0.2, 0.3 milliseconds, right? Let me start the first iPerf3 session. Okay, as you can see, the latency already jumped to more than 100 milliseconds. Start the second one, start the third one. So this is the total latency. As you can see, it keeps changing. Basically, it's about 100 milliseconds. That's the Bufferbloat problem. Because this latency is pretty high, you cannot have a smooth internet gaming, and you cannot have a good Zoom meeting or Skype call. Even though currently my internet speed, I specify, okay, the expected ISP speed is 1 gigabits per second for both down rate and up rate. Why? Remember, we are using the 1 gigabit port, right? So I still have the huge latency. That's the problem. Let's see whether the smart queuing can resolve it. Before enabling smart queues, there are 2 things I need to mention. First, in the SSH window, let me launch the top command. As you can see now, even though the system is super busy, it's still more than 50% idle, and the software IRQ is just a little bit more than 20%. Even though the system has very demanding internet activities now, the router can handle it without problem, but we have the serious latency issue now, right? And the second thing I want to mention is, if you are familiar with smart queues, especially in the UniFi case, let's say if you move on to the small I icon, it mentioned it's not recommended for connections faster than 300 megabits per second. In my understanding, the 300 thing, basically it means if you have a very high-speed internet, maybe you don't really need the smart queues. In Ubiquiti's opinion, maybe it's not worth it. But you can see, even I have super fast internet connection in this testing scenario. I have 1000 download, 1000 upload speed. Even it's super high, I still have the high latency issue, right? Let's see whether even in this situation, in this non-recommended situation, whether the smart queues can help. click this enabled button and let me specify the down rate and up rate. The rule of thumb is you put something slightly slower than you expected speed as starting point. You can fine tune it. You can say 80% or 85%. In my testing, let me simply say 800 for both, which means I use 80% of the total speed limit. Apply it. Okay, it's effective now. One interesting observation, see this Linux network history. Immediately after I enabled the smart queues, the total throughput dropped. Why? Apparently because I specified the slower down rate and up rate, right? That's the root cause. Many people complain why I enabled smart queues. I have worse internet speed. That's not the point of smart queues. For smart queues, you need to check another thing, which is here. Have you noticed the dramatic change in the time part? Now the latency is back to normal. It's under 1 milliseconds. Even though the other 3 sessions, they are still doing their heavy drops. Here for my ping session, I have very low latency already. That's the effect of smart queues. In this particular example, my buffer bloat issue has been resolved. Then let's go back to the SSH. As you can see, remember previously the idle is 52%, now it's 47%. So by enabling the smart queues setting, it only cost the system maybe about 5% lower than 10% CPU. The system is still pretty idle. At least the preliminary conclusion for UDM Pro is it doesn't matter whether you enable smart queues or not, it won't really harm your system performance too much because the hardware is powerful enough to handle it. But whether it's the same case for, let's say, UDR or Uxg Pro, which have much worse hardware, let's see later. Before moving on, let me show you one more thing in SSH. Remember, before enabling smart queues, I show you the queuing discipline, right? Let's do the same thing. Let's see what's the change. This is the S8 part for my WAN part. It's using HTTP and fair queue Codo queuing discipline for the WAN part, and this is only for upload. How it deals with the download, it's handled by a special IFB interface. It's IFB0. It still uses HTTP and fair queuing Codo, a similar way to handle the traffic control. I won't talk about the details. If you are interested, please check my previous video. Okay, now we are ready to move on to the third way to test Bufferbloat. In this way of testing, you need to install some third-party tools. On the screen, I show you 2 web pages. First one is from bufferbloat.net. It introduced its custom way to do the testing, which involves a tool called Flint, which I show you in the right side. So if you visit this page, it will tell you how to install the free Flint in Linux and how to execute the test. I won't go through the details. They are pretty straightforward. Let me simply show you how it works. Now we are ready to run the Flint command. As you can see, it will run all the pre-designed testing and run for 60 seconds. The host name is this Linux server machine. Give it a unique name and then output to an image. That's it. In the Linux server, you can see the network is warming up. Okay, now the upper limit is about 1 gigabits, exactly my line speed. And in the client side, it says it will run for 70 seconds. I believe the 10 additional ones are for warming up. And in the SSH part, you can see it's 60 idle. In this mode, I'm using all the bandwidth of the WAN part, and the system use about 20% of CPU to support it. Nothing's special. Let's wait till the end, then we can examine the generated image. Okay, it's almost done. Image generated. Let's go to File Manager. See the latency. The third part is 100 millisecond, pretty high. And see the messy chart. That implies the jitter is pretty high as well. Jitter means the latency is not stable. Sometimes it's fast, sometimes it's slow. That's exactly we encounter. Let's say you do a Skype call. Sometimes you have voice problem, sometimes you don't. Okay, so it proves before we enable smart queues, the situation is pretty bad. High latency, high jitter. Now let's enable smart queues. I already enabled smart queues in the client side. Let me run the almost identical command. The only difference is this time I outputted to another image. Let me run it. Similarly, it's warming up. The interesting observation is now the upper limit is lower than 1 gigabit. Now it's close to 800, exactly like what we specified here. And in the SSH session part, you can see the CPU idle time is not changed at all. The system is even more idle than previous case. Even after enabling smart queues, it really doesn't tax the system too much or at all. Let's give it some time. Yeah, image generated. Let's compare these two images side by side. Look at the third chart. You can see the latency is about 20, right? Dramatically improved from 100. Then it's less messy. That means the jitter situation is also improved. The testing result means the same thing as our previously completely manual testing. By enabling smart queues, it resolved the Bufferbloat issue, which is high latency, high jitter. Now we are good with how to test Bufferbloat. We are confident, okay, smart queues can really address the issue. The second part of the video, we are going to look into the 4 different UniFi routers to see whether they have different performance when it comes to smart queues. We already checked the Uxg Pro, right? Then let's look into the other 3. The next router we are going to check is the old Uxg Pro. It only has 2 gigabits 1 ports, so I'm using one of them to connect to the Linux server in my home network, and I connect the client Linux using 1 gigabit to the LAN part. Pretty simple network diagram. Let's jump to the testing. Okay, we are back to the familiar screen layout, but this time is for Uxg Pro. In the UniFi controller, I already disabled smart queues, and for expected ISP speed, I set to the same gigabit speed, and in the SSH, I already launched the top command. In the server side, similarly, 3 separate IPv3 servers, and here I use a activity monitor to monitor the network history. And from the client side, I already typed the 3 different IPv3 client commands. In the fourth window, I'm going to ping the server just to see the latency. First, let me start the ping. The latency is about 0.645 milliseconds normal. Then start the first IPv3 client. This time the latency jumped to 6. Start the second client. Jitter is serious, but the latency is still about 6 or 7. Start the third one. Yeah, a little bit changed, but still below 10. Pretty good result. To be honest with you, a little bit surprised because the result is better than Uxg Pro. Then let's enable the smart queues. Let's see what's the change. Yeah, by the way, before we do that, let's check the SSH. So you can see pretty idle. In the network history, you can see the total throughput is close to 1 gigabit. Everything's normal. Now let me enable smart queues. I will set to the same 800 down rate and 800 up rate. Apply changes. Now let's check the difference. After some change in the network speed, as you can see, now it's stabilized at about less than 400 megabits. Very disappointing. And in the right side, let's see, the latency is just slightly improved, not too much, but even before that, it's not too serious. Then let's check the top session. See, the CPU is almost 100%. And the throughput is just less than 400. very miserable. Let me try one more thing. You may know for Uxg Pro, it uses hardware offload to support DPI. I'm just curious whether currently, when I already enabled smart queues, whether the DPI is still on. Let me check it. Setting shows the DPI is still on. Then let me try to enable thread management. More specifically, IPS, enable all. Apply changes. Give it some time. Yeah, you can tell from the Linux server network history, it's fluctuating and now it's below 300. Apparently, DPI, smart queues, thread management will kill the performance. I believe that's not a surprise because the weak hardware of Uxg Pro, this is expected. It's time to look into the latest router from UniFi, the UDR, UniFi Dream Router. As you may know, it has much weaker hardware than UDM Pro or Uxg Pro. As the other two routers we already tested, Smart Queues setting is disabled, the exact same layout. Start the ping. Okay, so the latency is already not super good, 1 point something. Start the first iPerf3. Okay, the latency jumped to more than 100 already. Start the second one, then the third one. Something's wrong in the third one. Okay, now let's check the overall throughput. Even though now I haven't enabled smart queues yet, the line speed for the one part theoretically is 1 gigabits. Here I'm only getting less than 800, which means without enabling anything, just to access the one part, the throughput cannot close to the line speed. So from the top session, you can see nothing's changed, right? Whatever key I press, it just doesn't respond. So what is showing is outdated already, which means the system is super busy now. It even cannot respond to my operations in the SSH session. That's the result of this super weak hardware. See the top session, it's refreshed. See what are the top threads. They are Ubiquiti report hang something. So basically the system detected hanging threads and it cannot respond. It's killing all the threads. I believe now whatever I do here in the UniFi network controller, it won't be effective. But let me try. See, I click the apply changes button, there's no response. So the system is hanging. Even though now the 3 iPerf3 sessions and the ping are still working, the device cannot respond to anything else. I believe the network controller is being restarted. Let me force the refresh of the network controller. Let me try to ease the system's burden by killing the iPerf3. Kill the first one. The system is still restarting, I believe. Finally, after about a minute, the network controller has been restarted. I'm trying to reconnect. In the past 1 minute, the top process has been Java. I believe that means the network controller is still restarting. Okay, several minutes passed. Finally, I'm back to the network controller. Let's try to resolve it. Let me enable smart queues, and for now let me keep our old settings for the other routers, which is 800 megabits, right? But I seriously doubt whether they will help, because as you may remember, before enabling it, our maximum throughput was even below this limit. Apply, activate it. Let me do the same thing. So the ping is still going on. Latency is 1 point something. Let me start the first iPerf3. The latency is over 100 again. Apparently the smart queues didn't resolve the high latency issue. Let's still start the other two iPerf3. And then from the Linux session, let's see what's the overall throughput. See, it's stabilized, but it's only about 500 something, which means the smart queues did limit the throughput somehow, but it didn't resolve our buffer bloat issue, which implies the down rate and the up rate were not set properly. So the current setting don't work. The system is restarting again. I want to change them to 500. That seems to be a reasonable limit based on the weak hardware. Let me see whether I can set it. Oh no. Again, the system is restarting. I give it several minutes. Let's try the third time. Now I make sure the SSH shows everything is quiet and the device is idle. I already enabled smart queues with 500 rates setting, and let's start the same testing again. Now the ping is going on. Let me start the first iPerf 3. See the immediate change. See the latency here. It's still 1 point something. That means the 500 settings really work now. Let's continue. Start the second and the third one. All the three iPerf 3 clients are running, and in the Linux side, you can see the overall throughput is a little bit lower than 500, and the top session is still running, not hanging, and the idle is 0, which means the system is really 100% busy, but it's still responding. Latency is still under control. So that means for the weak hardware UDR, we cannot set the down rate and the up rate to super high value, but at least in my case, 500 works and the system is still responding. Finally, this is the hardest one. Let's move to the Uxg Pro, the newest router with the best hardware. Let's see how it behaves. This is the last router for this video, the Uxg Pro. Just like UDM Pro, Uxg Pro has two WAN ports, a 10 gigabits port and a gigabit port. Just to be fair with the other routers, I'm going to use the gigabit port for the testing because it's more close to the internet speed we can get nowadays. And as you can see, I have the smart queues disabled. Before we start testing, let's check the Ethernet 0 port. What's the queuing discipline setting? Because as I mentioned, there are two WAN ports. Each internet interface will have its own queuing discipline settings, its own smart queue settings. Let's see what's the current queuing discipline. Yeah, it's MQ plus 4 first in first out fast queuing disciplines as expected. Let's start the ping here. And just like UDM Pro, the latency is super low. Good sign. Start the first iPerf 3. In ping, it's dramatically delayed already. Start the second one, third one. In the Linux side, you can see the throughput is perfect. It almost exhausts the line speed, which is 1 gigabit. But in the ping side, as you can see, the delay is about 100 milliseconds, right? In real world, you may already feel the internet issues. So let's see whether smart queues can resolve the issue. Smart queue setting, check enabled, and just like UDM Pro, I set it as 800. Apply changes. Effective now. Let's check the queuing discipline now. Yes, it's changed. Becomes HTB and then FQ codel already. Okay, everything's expected. Because I haven't stopped the 3 iPerf 3 sessions and the ping, you may already notice the difference. In the Linux side, the total throughput dropped because we set the slightly lower down rate and up rate, right? Which is exactly expected. But in the ping side, as you can see, the latency is dramatically reduced. Now it's back to normal. Uxg Pro behaves the same as UDM Pro. The smart queues setting greatly improved the performance and resolved the Bufferbloat issue. Okay, after this long video back and forth settings among 4 routers, finally we can end this video. My conclusion is for the old Uxg Pro, the smart queue setting really doesn't help much. And for the UDR, the hardware is so weak, you need to be very careful if you want to enable the different settings, and you need to carefully set the down rate and up rate. For UDM Pro and the Uxg Pro, the performance is super good and the hardware is so powerful. Even after enabling smart queues, the system performance is not decreased at all. Okay, thanks for watching.